Now let's understand extended transition function. Now in simple transition function, delta is q cross sigma goes to q. The DFA is in some state, it reads a symbol and it goes to next state. For example, delta a comma 1 equal to b. Transition from a on 1 goes to b. So here we process only symbol. In extended transition function, we process a string. Extended transition function is denoted as delta star or delta cap. So delta cap is q cross sigma star goes to q. DFA is in some state. From there, it processes some string w from sigma star and it goes to next state. Now let's understand this using one example. So what is delta cap? B001. So B on 0 goes to C, C on 0 goes to B, and B on 1 goes to A. So delta cap B001 is A. So in simple transition function, it is q comma a is equal to qn. Here a is a symbol. In extended transition function, delta cap q comma w is equal to qn. W is a string from sigma star. Now in exam, you don't have to write all of these things. You can simply do it manually. So what is delta cap A0101? So here you have to begin from A and then process 0101. So from A 0101 you get C. Delta cap C 0011. So here we have to start from C. It is in extended transition function, it is not necessary that you should start from initial state or start state. In the function, it is specified from where you have to process the string w. So we have to process 0011 from C. So from C 0011. So you get C itself. Now again, in simple transition function, here you can process a symbol. Here you have to process a string. Epsilon is empty string. So you should know what is extended transition function while processing epsilon. So what is delta cap A on epsilon? So for any state, if you process epsilon, you remain in the same state. So A on epsilon, you get A itself. Delta cap B on epsilon, you get B itself. So this is about extended transition function. Now let's understand how a DFA accepts or rejects a string and what is language of a DFA. Now if delta cap Q0W belongs to F, then DFA accepts W. If you process a string W from initial state and you reach to some final state, then the string is accepted by the DFA. If you reach to some non-final state, then the string is rejected by the DFA. And language of a DFA is defined as W such that M accepts W. For a DFA, the set of all the strings accepted by the DFA is language of the DFA. Or you can say that L of M is equal to W such that from Q0, if you process W, you reach to final state. Now let's understand using some examples. Now here one important thing is that while deciding whether a string W is accepted by DFA or not, you must process string starting from Q0. Here extended transition function particularly mentions Q0. Here you cannot take any other state. Here you must take Q0, which is initial state or start state. And second part is that you check whether the processing ends in final state after completely processing W. You cannot take decisions somewhere in between. First you completely process string W and then check whether you have reached final state. So 0 1 0 0, initial state is A, string is 0 1 0 0. So 0 1 0 0, you reach to B. B is not a final state, this string is rejected. Then epsilon. So from A, if you process epsilon, you reach to state A only. A is a non-final state, this string is rejected. 1 0 1 1. From A, 1 0 1 1, you reach to C. C is a final state, this string is accepted. 0 1 1. 0, so we start from A, initial state, 0 1 1. You reach to A itself. A is a non-final state, this string is rejected. 1 0 1 0 0. From A, 1 0 1 0 0. You reach to state C, it is a final state, this string is accepted. So first important thing is that while deciding whether a string is accepted or not, you must start processing of the string from initial state. Second thing is you complete the processing of the string and then check what is the state you have reached. If you reach to final state, the string is accepted. If you reach non-final state, the string is rejected. And language of a DFA-M is set of all strings accepted by the DFA. So we will consider a simple example to understand language of the DFA. So this is given DFA, P is start state, Q is end state. Input alphabet contains only one symbol A, transitions handle symbol A. Now language of DFA is W such that M accepts W. Language of the DFA is set of all strings accepted by the DFA M. So we have to figure out what are all strings which are accepted by this DFA. Now what is the smallest string accepted by this DFA? So it is string A. From P, if you process A, you reach to Q. Q is final state. So string A is accepted by this DFA. Now if you consider string A power 2 or AA, then from P, A, processing ends in P. P is a non-final state. So string AA is rejected by the DFA. String AA is not part of the language of the DFA. Now if you consider string A3 or AAA, then from P, A, we reach to final state. String A power 3 is accepted by the DFA, so it is part of language of the DFA. And then A power 5, A power 7 and so on. These strings are accepted by the DFA and this is language of the DFA. So for this language we can say that L of M is equal to A power 2n plus 1 such that n greater than or equal to 0. For n equal to 0 we get A power 1. For n equal to 1 we get 2 plus 1 3, A power 3. For n equal to 2 we get 4 plus 1, A power 5 and so on. So this is one simple example to understand language of the DFA. Do not ignore the notes. You will understand some points easily and clearly if you go through the notes. Do not ignore the notes. You will understand some points easily and clearly if you go through the notes. Now this is formula for extended transition function. In exam, you don't have to calculate by formula. You simply refer the state diagram and go for it. This part is only for information purpose. These calculations are complicated. You will end up wasting your time and confusing yourself. So if you find this part complicated, you can simply ignore. This is only for information. So delta cap Q on epsilon goes to Q itself. If you process epsilon from a state, you remain in the same state. Now consider delta cap Q on XA. X is a string, A is a symbol. If you have to find delta cap from Q on XA, first you figure out delta cap from Q on X, you get this state and then go for symbol A. This is a recursive definition. Let's consider one example. We have to figure out extended transition from state C for string 01. For convenience, we write it as epsilon 01. Now, before we calculate transition on epsilon 01, first we will calculate transition on epsilon 0, then we process 1. So this becomes delta cap from C epsilon 0. First you find out this answer, then you process 1. Again here we apply the recursive definition. First figure out delta cap C epsilon, then process 0 and then process 1. So this becomes delta cap C epsilon, then process 0, then process 1. So now we have this formula here. From C, if we process epsilon, we remain in the same state. So this becomes C, 0, 1. Delta cap C on epsilon gives C itself. Now C on 0 goes to B. B on 1 goes to A. But we don't, in exam you don't have to do all these things. You simply see C on 01. C on 01, it gives A. If you find this complicated, you can ignore this part.